Hello, this is Steve Groven, and today's topic is fluids and pressure. So, to introduce pressure, let me toss a few words at you. Burden, strain, tension, strength, squeeze, stress, and of course, pressure. All of these words are related. All of these words you can look up in a thesaurus and you can see how they are related. Anybody who is feeling the stress of the end of the year is, of course, feeling the pressure, and you can feel the pressure or you can feel the stress. But what exactly is pressure in a physical science sense? Okay, so let's start out with the definition of pressure. Pressure is the amount of force exerted per unit area on a surface. Okay, more on that later. In fact, this particular definition is going to include a mathematical formula. Okay, so what's a fluid? Any material that can flow that takes the shape of its container. Includes liquids and gases. Liquids such as water, gasoline, oil. You notice in the picture here that I gave you, water in a water glass, or water in a wine glass will take the shape of the wine glass. It will also take the shape of the bottle. And then, of course, gases, helium, argon, anything that you can put in a balloon. Well, probably not argon. Um, by the way, despite the definition, fluids do not, and I don't care what the internet says, it does not include cats. I just wanted to dispel that rumor right off the bat. Okay, so first off, I want to show you a little video that I made not too long ago. I'll just let the video speak for itself as soon as I get it working. So here's a little prank that you can play with a 2-liter bottle and some colored water. So you get your 2-liter bottle, you get colored water. Right on the bottle, do not open. This is very important. You need to play around with the human mind. Then you need a push pin. And what you need to do with the push pin is poke holes around the bottle. Now, as you can see, you really can't see the holes. All right. So, once you get the bottle in there, hide or just get out of the way. Let somebody come in, see what happens. Okay, so I'm going to have my son actually open the bottle, and we'll see what happens. And there you go. Okay, so if you do this right, whoever is opening the bottle should be getting a nice little spray of blue dye all over them right now. Okay, so what's happening? Okay, as we know, water is a fluid, and all fluids are exerting pressure, but what direction is that pressure going to be? Now, if you look at the direction that the water is flowing from the bottle, it's flowing in a perpendicular direction from the bottle. It's going straight out, so what that tells me is that the fluid is actually going in all directions, or the pressure is going in all directions. Okay, how else do I know this? Well, let's take this for example. Okay, so every time you blow up a balloon, unless you have a novelty balloon, the balloon is going to be in a round shape because air is also a fluid, and fluid is going to exert a pressure. And in this case, the pressure is going to be exerted in all directions. Okay, so, sorry about that rude noise there. Whoa, okay, I'm going to have to stop the flood here, and there we go. Fluids exert pressure in all directions. Okay, so again, very simple point. Fluids are going to exert pressure in all directions. Of course, in the case of a liquid, you notice that in the liquid in the bottle, there was a certain amount of, well, it was level at the top, and it's level at the top because gravity is, of course, pulling that down. Well, gravity is also going to be pulling down on the air or on the balloon, and I'll talk about that more in another video. But let's talk a little bit about soap bubbles. Okay, so question: why are soap bubbles round? Okay, as you recall from the previous video, one thing that we do know is that air is a fluid. And because it's a fluid, it's going to exert pressure evenly in all directions. Well, because fluids exert pressure evenly in all directions, here, let me get rid of my top photo there, revealing a little line drawing I put up there earlier. It's going to exert pressure evenly in all directions. And anybody in a math class hopefully knows the definition or knows the formula for spheres or for the for like the surface area of a sphere versus the volume of a sphere. And if you notice with spheres, you're going to get, if you compared a sphere to a cube, for example, you'd notice that the volume, if you had the same surface area for a cube versus a sphere, the volume of the sphere would be much greater because that is going to be the most efficient or the mathematically most voluminous shape. A cube, on the other hand, it's not going to give you a lot of volume, not compared to a sphere. Okay, so basically, why are soap bubbles round? Because the bubble filled with air is going to expand in all directions. Okay, let me go on to the next page here. Okay, so the last topic that I'm going to give you today is just using the mathematical formula, pressure is equal to force divided by area. Now, one thing I want you to remember about force is that's also the same definition. A force is also defined as your weight. Okay, now if you notice in my formula that I gave you, pressure, PA is equal to force newtons divided by area meters squared. Well, PA is the Pascal, which is the SI unit for pressure. 1 Pascal is equal to 1 Newton per meter squared. Okay, now let's see if I can't get this working right today. I haven't had very much luck drawing on my screen. So find the pressure exerted by a 3,000 Newton crate that has an area of 2 meters squared. Okay, so remembering again that pressure is equal to your force divided by the area. Okay, let me write that again over here. Okay, now this time I'm just going to add the numbers in there. So pressure is equal to 3,000 newtons, the force, divided by 2 meters squared, which is the pressure. Oops, that didn't come out very well. It still didn't come out very well. Okay, so you don't even really need a calculator to do that calculation. 3,000 divided by 2 is going to give you 1,500. And the units, of course, are going to be in pascals because 1 Pascal is equal to 1 Newton per meter squared. So our answer is going to be 1,500 pascals. I'll just circle that as our answer there. Okay. Okay, so let's turn that around. Now, what if I want to find the weight of a rock that has an area? This time, I want to find the weight. I know the pressure, and I know the area. So what we can do is we can take this formula here and turn it around. Algebra students will notice all you have to do is just multiply both sides by the area, leaving force by itself, force equaling the pressure multiplied by, I'm going to put parentheses this time, multiplied by the area. Okay, so just a very simple algebraic manipulation. Complete the equation. In this case, the pressure is equal to 250 pascals, and I want you to remember the Pascal is equal to 1 Newton per meter squared, so I can just kind of stick that up there, Newton per meter squared. That came out a little better. And now I'm multiplying it by 10 meters squared. Okay, sorry I went off the screen there. So the meters squared are going to cancel out, leaving me with newtons, which is the unit for force as well as weight. 250 times 10 is going to get me, again, another question that you really don't need a calculator for, 2,500. Your answer is going to be 2,500 newtons. Okay, so using the formula is really simple. Manipulating the formula algebraically is also really simple. You just got to remember your algebra. Okay, and that's all I have. There will be more videos in this topic to follow. All right, thank you very much, and I'll talk to you later.